So why don't we take a look at, see where we're at so far in this little assignment. Just gonna zoom in a bit. So, does anybody remember what there was a quick way of finding the domain for logs. Does anybody remember how to do that? Sure, Lily.
X minus h equals 0.
Oh, so that's really technical. You're absolutely correct. Nice simple way to think of it, whatever's in that box, so log of anything you want, that has to be greater than 0. So what I'm looking for is I want to make for x minus 1 greater than 0, which is exactly what Lily said, but she had an x and an h and some other stuff in there too. So, so if I solve this inequality for x greater than 1, x has got to be greater than a quarter, so it should be c. Okay. Okay, how about finding the asymptote? How would you find the asymptote quickly for the log? Let's see here. Danny, do you know how to find the asymptote on this one?
Are you thinking with brackets? Cannot be 0. So the asymptote will be 1 that expects.
Exactly. Yeah, okay, so anything inside these brackets here, it can't be equal to 0. That's where the problems start for the log. So that's where the asymptote marks the border. You can't go over that. So this will be where x plus 3 equals 0. That's where we'll find the asymptote. So it's going to happen at x equals negative 3. Okay. Be careful, this here is not the asymptote. That's the asymptote on an exponential, right? So that's not the asymptote. It's one of the ones they're trying to trick you with here. Okay, the next one says, determine an exponential function in the form 3x minus h plus k with y-intercept 5 and asymptote negative 4. So which one's easier to figure out, the asymptote or the y-intercept? Which one can you find out pretty quickly, the asymptote or the y-intercept? Yeah, the asymptote is the quickest one to find. This is where we usually find it. Normally the graph goes like this, right? And it's everything above 0. So whatever we add or subtract shifts the graph up and down. So what we got now is, now we have a graph that's been moved up to negative 4. So I know that this is the form that I'm looking for. Okay, so now what I have to do is figure out how to use this information. I remember when you hear y-intercept, you want to think x equals to 0. So now I can solve a little equation by writing in 5 equals 3 to the 0 minus h minus 4. And 9 is 3 to the negative h. So if you really want to get, you could go like this. So h equals, I guess it would be negative h equals 2, h equals to negative 2. But remember the form that we started with, if we put it back in, that'll be minus minus 2. So subtracting the negative makes it positive. It should be 3x plus 2 minus 4. Okay? Now, exponential equations. What are we going to do to relate a quarter and an eighth? You guys have like a turkey lunch? Is that why everyone's sleepy? Go ahead, Jeremy. 2, yeah, 2 is what we're going to try to relate them with. So this would be 2 to the negative 2, 1 minus 2x, and this would be 2 cubed to the x minus 3. So that leaves me with an equation like this. So I have the same base, so the exponents must be equal. Negative 2 plus 4x has to be equal to 3x minus 9. So if I rearrange this, x should be negative 7, which is a. Okay. Now the next one is a little trickier, so we're going to walk through it together. Basically there's so many letters in it that it tends to scare people. but I've seen this as a written question as well in previous exams, usually worth about 5 marks. So here's the thing, okay? We have all these letters here, but we're just going to pretend that there's actually numbers. What would we do if there were different numbers here, okay? Our first strategy would be, can we make a common base? Okay, well, probably not, because I don't know how to go from A to B, right? But if I can't find a common base, what would be the next thing you do to try and solve an equation like this? Yeah, you're going to have to use logs. It's obvious because the answers all have log in them. But you're going to have to log both sides. So this is the strategy that you'd have to go into, is we'll log both sides of the equation. And the reason that this becomes helpful to me is these exponents can now be brought down as multiplication. So this is going to become x minus 2 log A equals x log B, log B. And I'm solving for x, so I want to move all my x's to one side and factor them out. This will be x log A minus 2 log A is x log B. And if I take my x's all on the same side, now I can factor them out. So x log A minus log B is 2 log A, and x equals, frozen, just a second. I think we were right about here before it crashed, so you probably figured it out while I was trying to get through the technical difficulties. Only thing left to do is divide. So B is the answer there. So one thing I'm going to do is I'm going to tell you, put a star beside this one. You remember in transformations when we did that question with the inverse and everybody kind of was like, oh, now I know how to do it. Same thing, if this one was to come up, it's one of those questions where it's not so bad if you've done it before, but if you've kind of like never seen it, it might be the question that stumps you. So it's kind of like that inverse question we did in transformations where at first it seemed like there was an impossible task to do. Okay, so I'm going to keep us moving here. We'll finish the first couple together. And after something like that, of course, you need a brain break, right? Something nice and simple. Changing, here's the base, here's the exponent, here's the value. So this should be 7 to the y equals x. So it should be d. Okay. Now we talked about this about a week ago, I guess, with inverses and how to do that. The first step is the same as it always was before. It was to switch x and y. So we would have 10 to the y. Well, of course, that's easy to fix though. Just went to sleep. Y minus 3 plus 4. And now, if we're solving for y, since y is an exponent, I'm going to need a log. So this will be log. Sorry, before I go to the logs. Okay, now all I have is one value, a base, and an exponent. So I can rewrite this as log base 10 of x minus 4 equals y minus 3. So y must equal log x minus 4 plus 3. So that'll be b. Okay. With log laws, this again is like a typical sort of question to test your knowledge of log laws. What would happen first in this expression? What would you need to work on? There's 1, 2, 3 log laws I can see that I'm going to need to do here. What do you think needs to happen first? Uh-oh. Yeah, EJ.
Put the 2 as an exponent.
Yeah, the 2, this is multiplication. Multiplication comes before the subtractions. So the 2 needs to be moved up as an exponent. So this would be log base A minus log B squared minus log C. Now all I have left are subtractions. So, I mean, we could go like this. We could say that's log A over B squared minus log C. And then if I divide again by C, it would be log A over B squared C. Now that's not the only way you arrive at the answer, which looks like D. That's not the only way you could arrive there. I know another student said, well, what if we went like this? I don't know how they, I'm not sure it's the first thing you'd come up with, but maybe it'll help you understand it a little bit better. I could also have done it like this and said log A, take away log B squared plus log C. Right? Factored out that negative. That way it would be log A take away. So adding them is the same as multiplying. Log B squared C. Now I've got a subtraction, so it will be log A over B squared C. So both get you to the same answer, but as long as you're comfortable working with the log laws, you should end up at the same place when you're done. Okay. So this time we're going to take a look if log x, or log A of x equals 3 and log A of y equals 4, can we evaluate this? Our goal is to get this expression in terms of log A of x and log A of y. So the first thing that we've got a problem with here is this reciprocal. But fortunately, being in Math 12 honors, I know that all I got to do is raise it to the negative 1. Okay? So that way I can get rid of that fraction. Be careful, the 2 right here, this 2 is not belong to any logarithm. That's plain old squared, like you know from before our class. This 1 here is the only thing that is attached to a logarithm. So that's the only thing that can be moved to the front. So the next thing I'll probably want to do is go negative log A of x, y, all squared. And now one more log law gets me to the answer. So this will be negative log x plus log y, and the whole thing is squared. So it says, according to the instructions, log A of x is worth 3 and log A of y is worth 4. So this is negative 7 squared, which is 49. So D was the answer there. Okay. In the next one, we're going to take a look at solving an exponential equation. We can go right to it as it is and divide. Or you could move it to the other side, that's fine as well. But I would assume most people probably just went right into this. Okay, so we're at the stage now where we have log base 4, so the arguments must be the same. So x squared plus 1 over 6 must be equal to 5. So x squared plus 1 should be equal to 30. So that means x squared equals 29, and x is plus or minus root 29. So we should double check our answers before we circle it for our choice in the log equations. If we put in positive root 29, then there would be no problem here. And if we put in negative root 29, similarly, they both work. So neither will cause any problems in the log function. Both are acceptable. Okay, so last one here. Max invests $5,000 at an interest rate of 6% per year, compounded monthly. What expression represents his investment after T years? So this is the starting amount, $5,000. Interest rate is $6,000, and we're compounding it monthly. So if we put all that into what we know, the formula that we work with, monthly means there's going to be 12 payments made, and that means there's 12 per year. So this would be 12T. So this is actually the answer, but what they've done in the multiple choice there is they've turned this into 1 plus 0.005. They've actually done the division, 12t, so it would be B. Okay? Okay, so I'm going to let you work on the second half of that review, and then we'll recap again shortly.